So we've got ratios. That's what rational equations are. Okay? We're comparing two things a lot of times when we're doing rational equations. We're going to have to write our own and then use the process to solve. It's going to require some critical thinking. Luckily, a lot of it's pretty formulaic. We're going to be using a lot of proportions. And what we need in order to write a proportion is think about some things that we're comparing. But just to start, I've got a simple rational equation with one fraction set equal to another. So what's always been my first step for solving a rational equation? Find my LCD. What is my LCD here? Okay, let's not distribute. Let's leave it factored. Let's take that headphone out. But my LCD is going to be the two factors, 3 and x plus 2. What do I do with that LCD? Can you be more specific? Multiply all the numerators. Excuse me. All right. So we're going to multiply all our numerators by the LCD. 3x plus 2, 3x plus 2. Okay, now what? Okay, cancel our like terms. X plus 2 here, 3 here. Keep going.
Then 3x plus 3.
No, you're not. You're thinking.
I don't equals 35.
That
No,
is 5 and x
5
plus 2.
plus 35.
5x plus 10.
10. Oh, it's 2.
That's 2.
Okay.
All right? Someone other than Micah. Now what?
Negative 2x.
Let's subtract the 3. So I end up with a positive 2x. What else?
Plus the 7.
Subtract the 10. I end up with a negative 7. Divide by 2. So I've got negative 7 halves. Is that an excluded value, or am I good? We're good. What is my excluded value? Negative 2. So it's not negative 2. Okay? So, simple proportion, same process, find the LCD, multiply, simplify. Alright? Now let's take this same idea, but we're going to move it into a word problem. Okay? So, we are comparing two things. When we're comparing two things, we're going to use a proportion. So I have a 170-pound person that weighs approximately 65 pounds on Mars, and then I want to know how much a 9,000-pound satellite would weigh on Mars. Yes, ma'am. Yes, but first I want to ask, what two things am I comparing? Okay, so I'm comparing their two weights, the person and the satellite. Okay, so I've got a person and I've got a satellite. All right. What else am I comparing? The weight on Earth and the weight on Mars. Okay, so I can write a proportion with the Earth weight over the Mars weight for the person, and I can write another proportion with the Earth weight of the satellite over the Mars weight. Now there's a little bit of flexibility in the proportions. You can write them in varying ways. You'll still get the same answer, but what's important is that the numerators have to represent the same thing, but on two different things. Okay? So notice how both numerators are Earth weight. Both denominators are Mars weight. If your numerator was Mars weight, then it'd have to be the same on both. You can't flip it. So, for example, if I had Earth weight over Mars weight, that would not equal Mars weight over Earth weight. Okay? Because now you've got the units switched. Okay? So it has to be consistent. Numerators should match. Denominators should match. Okay? So keep that in mind when you're writing the proportion. And then the two things that I'm looking at are the person and the satellite. Okay? So, what's the person's Earth weight? What's the person's Mars weight? What's the satellite's Earth weight? What's the satellite's Mars weight? X. Because we don't know what that one is. Just follow our same process. We're going to go ahead and find our LCD, which is going to be what? 65x. And what are we going to do with that 65x? Multiply everything by 65x. Okay? So, now that I'm doing the multiplication, the next step is to cancel. What am I canceling the first one? Leaving me with 170x. Okay? What cancels in the second one? Leaving me with times, which is 585,000. Last step. Divide by 170. Giving me a Mars weight of approximately 3,441 pounds.
What was the answer for the last example before that? How would you write the answer? Proportionally, right?
It was -7/2.
So what's the difference between proportions?
Proportions are ratios. Ratios are rational. Since I have an equation, it's a rational equation. Okay? Now, second type. So the first one we were comparing two things. Now I want you to notice what's a little bit different about this scenario. We have an experienced roofer who can roof a house in 26 hours, and a beginner needs 39 hours to do the same job. Okay? How long will it take if the two roofers work together? So instead of comparing two things, we're adding two things together. Okay? They're working together. So that's going to be a little bit different in the formula. Don't fall into the trap of thinking it's going to be an average, because it's not. Because they're not doing the same amount of work. If they're working together, the experienced roofer is going to work faster. He's going to get more of the job done. But the beginner is going to take longer to do his job. So in the end, the experienced roofer will do more, but working it together, they'll finish faster. Okay, so it's not an average, but they are working together, which is going to reduce the total time. So there's a couple things we need to look at. It's very formulaic in the way that it's set up. We usually look at 1 over whatever it is that we're talking about. So time or whatever the comparison ends up being when they're working together. Usually it's time. Okay? So this is kind of one job and then how much time. Okay? It's how much time does it take for them to do one job. And what we have is an experienced worker plus a beginner worker and then their total time. So all the ratios are going to follow this idea of a unit rate, 1 over the time it takes to do something. Okay? So for the time it takes to do one job, our experienced worker, how long does it take him to do that one job? 26. And then with our beginning worker, how long does it take him to do that one job? 39. Okay? You can also look at it this way. This 126 for our experienced worker, in 1 hour, he completes 1/26 of the job. In that same 1 hour, the other worker will complete 1/39 of the job. So they're completing part of the job. So these each represent how much of the job they're getting done every single hour. Now we need to figure out, for them to do one job together, how much time does it take for them to complete that whole job? Okay? So that's what we're solving for. It's very formulaic. It's going to be very similar with a lot of these types of questions, and SAT loves these types of questions where you set up these fractions, these rational equations of this much of the job plus this much of the job equals the total amount. All right. So the other idea could also ask how much of the job they'll get done in 1 hour. So how much time to complete it? So now I've got my rational equation. So now I just use my steps for solving a rational equation, which is going to be what? Find the LCD. Get out your calculator. I'm going to show you a trick because those are some really big numbers, right? That'll be annoying to find. The calculator can do it for you. Do that. Do that. Do that. All right. So what you want to do? Your lovely little math button. You click on that. You want to go over to the column that says number, N-U-M, for number. And you want to go over to that. And then remember, LCD is synonymous with LCM. So you want to go down to number 8 for the LCM. And you click on that. You type in the two numbers that you want to find the least common multiple of, which is 39 and 26. And it tells you your LCM is going to be 28 or 78. Right here. Okay, so you can put in, it only works with 2 numbers, so you can't do 3 or 4, but you can pick any 2 numbers, put them in, and it's going to tell you the LCM of those 2 numbers. Okay? So I know my LCD is going to be 78, so let's go back here. And so my LCD is 78, and what else?
T.
And the T. Okay, don't forget that variable. So my LCD is 78T. What am I going to do with all these now? Multiply 78T, 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 and then we simplify. What's 78 divided by 26? 3. So I get 3T plus 78 divided by 39. 2T equals 78. Now what? Combine like terms. Divide. Okay. Now, when it's asking for time, 78 over 5 hours doesn't really make a whole lot of sense, right? So go ahead and do the division and round it. What'd you say? Yep. 15.6 hours. So working together, it'll take them 6 hours to complete the job. Now in that time, remember the experienced roofer will get a lot more of it done. Say that again?
How do you know?
Well, they're both going to be working 15.6 hours.
Oh,
They're going to be working together for 15.6 hours to finish the job.
So without the calculator,
Write out your multiples of 26 and 39. So 26 times 1, 26 times 2, 26 times 3, and then 39 times 1, 39 times 2, 39 times 3, and then until you find a common number. So that was working together. The first one was comparing 2 things. Okay? So those are kind of the 2 general formulas you're going to have. It's working together. You're going to have this kind of addition idea, this addition process, okay, with a total. If it's comparing 2 things, we're setting up a proportion. So I've got the speed of a lazy river's current, 5 miles an hour. A boat travels 20 miles downstream in the same time as traveling 10 miles upstream. So, do I have 2 things working together, or am I comparing 2 things? I'm comparing 2 things. What 2 things am I comparing? Downstream and upstream. Downstream, downstream, and upstream. Okay? Now, here's the important thing. In order to compare these things, something has to be the same. Okay? Something has to be the same. What's the same in this situation, regardless of going downstream or upstream? The speed is the same. What else?
current,
That's the speed. Yep, the current. But what about its trip downstream and its trip upstream? The same. They're not traveling the same distance because one way it goes 20 miles, the other one it goes 10 miles. While the speed of the boat in still water is the same, the speed in each direction is not, because upstream is going slower, downstream is going to go faster. Okay? So while the stream is the same, its speed is constant, the rate of the boat is not the same. This is our last example. Okay? So we need to remember that time, since time is the same, we're going to take our distance formula and we're going to rewrite it in terms of time. Okay? So if I have distance equals rate times time, and I want to get time by itself, I divide by r, and that gives me time will be the distance over the rate. So I'm comparing the distance downstream over its rate downstream plus or equals the distance upstream over the rate upstream. Okay? So what's the distance downstream that it went? 20 miles. Okay? Now, I don't know the rate of the boat. Okay? I don't know how fast the boat is going on its own. I do know how fast the river is going. So if I have the speed of the boat and I have the speed of the river going downstream, what can I do with those speeds to find its actual rate? If I have the speed of the boat and if I'm going downstream, does downstream speed it up or slow it down? It speeds it up. So we add them. The rate of the boat plus the rate of the river together gives its total speed. Okay? So the rate of the boat plus the rate of the river gives me the total speed. What about going upstream? What's the distance? 10. Is upstream going to slow it down or speed it up? Slow it down. R minus 5. Okay? Because going upstream, you're going against the river's flow. So the river's pushing against you while you go upstream. Downstream, you're working with it. Okay? Have any of you ever been in like a lazy river for a water park? Okay? If you're swimming with the flow, you go a lot faster. That's going downstream. But if you try and catch up to someone that's behind you, you got to swim a lot harder to get up to them because you're fighting against the current. So now I've got my rational equation. That was the hard part. You guys know how to solve this. Okay, what's my LCD? Yep, r plus 5 and r minus 5. What am I going to do with those? Multiply everything by r plus 5 and r minus 5. R plus 5, r minus 5. Keep it going. Over here. Okay. Minus 100 equals plus 50. So I've got 20r minus 100 equals 10r plus 50. Okay. What else? Okay, so I get 10r equals 150. So the rate is 15 miles per hour. Okay, that's pretty much it. The processes are going to be pretty formulaic. Figure out, are you comparing two things, or are you working together? Make sure that your proportions are consistent. Notice how the numerators always match. The numerators always talk about the same thing. One job, or one distance, or the weight on Earth. The denominators always talk about the same thing. The rate of the boat, the time it took to complete the job, the weight on Mars. Okay, numerators and denominators have to be consistent. Other than that, you can set up your proportions pretty easily and then just solve the same way that you've been solving. Questions, comments, concerns, queries, or